Hi everyone, welcome back to my channel. Again, my name is MNLG, your science teacher. And for today's vlog, I welcome you for another new topic, new learning or meaningful experience with me as your teacher as I discuss to you the topic about atomic charge. And I'm sure that you have learned so many things last week because we are done discussing, or I share already with you the concept about atoms and its subatomic particles. So we have three, like proton, neutron, and electron. And for today, I'm gonna discuss to you a new topic, which is atomic charge. And also, I'm gonna share with you cation, ion, including how to calculate the electrons if the atom is not neutral. So today, samahan niyo po ako tuklasin ng bagong topic na ito. So before that, please watch this. Alright, so thank you for watching that short introduction. So I think all of us now are ready to listen. Okay, so to start our lesson, let me share first or discuss with you the concept about periodic table. Okay, as you can see the screen class, I'll show an example of a periodic table of elements. So what is this? Okay, this consists elements with their respective atomic number, atomic mass, and of course the symbols. So okay, my question is, why learn periodic table? We need to learn periodic table because the concepts in there or the information in the periodic table is very essential for us to learn this topic, because in periodic table, as we all know, it consists of atomic number, atomic mass, and of course element and its symbol. So including the charge class, because our topic will evolve in discovering atomic charge. So those are the things that we need to learn. That is why periodic table or familiarizing periodic table is very essential. Okay, in the periodic table class, as you observe that there are numbers indicated at the left side, in the top part of that periodic table. So those indicate that arrangement of the elements are different. So it could be arranged into family, arranged into row or period. So you have seen in the left side of the periodic table, there is a number 1 to 7, and those are row or period, and those numbers written on the top of it are family or group. So we have 1 up to 18 in this periodic table. So as you can see, iron or Fe is highlighted. So we have this iron or has 26 atomic number, and of course we have mass 55.845. So if we're going to round it off, it became 56. So remember that in the actual writing, so do not be confused on that, because you know already that atomic number is lesser compared to its atomic mass or mass number. So again, atomic number, it's easy for us to determine because atomic number is less compared to atomic mass. I hope that it's clear. Okay, to continue, let's now go straight in your module. So kindly get your module. And before we go on to that, so as a reminder, please get your pen and paper with you. Then of course, jot down the most important thing that you have learned from this concept. So let's go straight with let's understand or study the concept. In the previous module, we learned about the different subatomic particles, and those are proton, electron, and neutron, or PNE, proton, neutron, and electron, and their corresponding roles in an atom. So what are their roles? So for example, this proton and neutron are found inside the nucleus, while this electron are found outside the nucleus. So again, it makes up the development of an atom. So it contributes to size and of course the mass of its atom. That's very important. Okay, so as promised, I will discuss again isotope. Isotope are atoms of the same atomic number but different atomic mass or weight. Okay, such atoms which have the same proton number. So proton can be written as Z or atomic number, but different values of neutron or N. So I'll be giving more examples on that later on. So isotopes occupy the same position in the periodic table. So example, we have carbon, hydrogen. To enrich your learning about isotope, I add this one. Isotope is an element that are made of one type of atom. But the atoms of an element can come in slightly different forms. Although atoms of the same element always have the same number of protons, they may have different number of neutrons. So let me clear this thing, that the atoms differ in this way are called isotopes. Okay, presenting now is an example of an isotope. So we, for example, two isotopes of carbon. So remember, so example here, carbon has a symbol or written as capital C. It is written or placed at the center. So we have here comparing the two isotopes. So it has the same atomic number. So look at that. So we have 6 and the other one 6. But it only differs, class, in terms of its atomic mass unit or mass number. So the first one, we have first atom, it has 12 atomic mass, while the other carbon has 13. So technically mass number is different. That is example of an isotope. So it has the same number of protons but differ in terms of number of its neutron. Of course, obviously the atomic mass. The isotopes of an element are virtually identical in their chemical reaction. So this time around, so we have 3 atoms. So this because they all have the same number of protons and the same number of electrons. So we have 3 carbon atoms here. So all of this have 6 number of protons or atomic number, but look at the mass number, so it differs, class. So we have 12, atom 1, 12, 13, and 14. So if we're going to analyze here, so since it differs with the atomic mass, so we'll be expecting that we could also have different number of neutrons. All right, because as a review, in getting the neutrons, you have to subtract, okay, mass number minus atomic number, or atomic mass minus atomic number, or it could be atomic mass minus number of proton. All right, so in your module class, you can see this one. It is being said that atoms that have equal number of protons and electrons are considered neutral. Again, equal number of protons and electrons are considered neutral. However, the number of electrons may change due to transfer of electrons from one element to another. So, the imbalance of the number of protons and electrons causes the atom to become charged. So imbalance. These charged atoms now are called ions. Okay, as you can see the module class, example given is sodium and of course oxygen. So now, so in the sodium class, we have this one dot. That dot represents the number of electron. And the other one here, we have also have oxygen. So we have 6. So if you can count the dots here, 1, 2, 3, 4, 5, 6. So remember, okay, that 6 is so it's number of electron. It's the outermost electron. It's dots. And again, you will learn that one when you will be in grade 9. Okay, so this will be more emphasized. So we have Na and oxygen. So for Na, so that arrow class, that signifies the transfer of electron, okay, from that dot going to the other element. So that indicates a transfer of electron, meaning to say that that electron has been transferred to oxygen, so to make it balanced, okay, to make it stable. Okay, to continue, so let me have a short background or short recall about atomic structure that we have last week. So we've learned about that atomic structure has all of this. So you have neutron, proton, electron. You can see the picture, class. It looks like solar system conceptualized by Niels Bohr. So in that center, we have this nucleus wherein if we are going to observe the structure of an atom, so we can have this. So we have charges, of course. We have electron, which is negative. We have proton, which is positive, and neutron, which is neutral, so no charge at all. So positive, negative, and neutral. And of course, we have these parts. We have nucleus, wherein neutrons and protons are found. And of course, this one, we also have this orbitals where electrons are found. Electrons are found outside the nucleus. In this table class, so you can see that, okay, it's being categorized, of course, the particle, electric charge, location, and particle symbol. So we have particle with proton, neutron, and electron. So the charge, positive for proton, as I have said a while ago. Neutron, no charge. Electron, negative. And location, nucleus, the other one is outside the nucleus. And the particle symbol, written small p, we have p, and then it has positive charge mark on top, at the right top, the right side. And we also have for n, so you can notice that that's 0. That 0 indicates neutral or no charge at all. And E, it has a negative sign written in the top portion at the right top most part of the symbol with E, and then negative. So meaning to say that that is electron. Electron is negative, NO, neutral, and P plus or positive. Okay, students, please focus on this. This is the most essential thing in this lesson. So generally speaking, the atoms have a neutral charge. So we have negative, positive, or neutral or 0. But if an atom gains electron, gains means accepting electrons from other element, it becomes a negatively charged or it will turn into negative ion. So maging negative pag ito ay tatanggap or mag-gain ng electrons ng isang element. But if the atom loses electrons, it becomes positively charged or positive ions. So everyone, and keep safe.